Oh, the programming assignment.
I think so.
It's written there, it's in the programming assignment, yeah. So let me project it so that we are on the same page. I think we are not on the same page on this one, I suspect. So let me try and project it. Remember, it's programming assignment 1 up to 6. At the moment, you're only supposed to do 1. That's all I've asked you to do. I've not asked you to do 2 or 3 or 4. If you don't know that, maybe that's the issue. But okay, so I've projected it. Can you see it?
Yes.
Right. So as of now, I want you only to do assignment number 1. We have not done enough for you to start doing assignment number 2. And when we have done enough for you to do assignment number 2, I will let you know. But as of now, I want you to do assignment 1. So let me read it. It says develop a standalone program. What I mean by standalone, it's a program that should run on a single machine. And this program should implement an online application, shopping application, or an online bookshop, right? That provides the following services: display the catalog, search for an item, search for a book, purchase a book, pay for it. Now, the following attributes describe a book as required. A book should be described by its title, by authors, the ISBN, publisher, date of publication. So that then you can search for that book by title, and I prefer you just choose maybe 1 or 2. You don't do too many searches. Just choose 1 and search by that, because this is about this course is about network programming. So I'm not so keen on fancy things. I want a basic program. I'm not so keen on fancy, what do you say, fancy user interfaces, because that's not the objective of this course. I think you've done those kind of things in other courses. Mine is the network programming part. So all those fancy interfaces that you may want to do, please leave them out. All those fancy searches you may want to do, search by titles, do search by what. I'm not so keen on those issues. So if you even decide you are going to allow user to search by title or search by ISBN, that's enough, as long as they can search. So I want them to be able to display the catalog, search for a book. Maybe I should even change it so that it says search for a book, purchase a book, and pay for it. Now it says, after that, it says the program should maintain a list of books in a text file, and I mean a text file. So don't bring in databases here. I mean a text file, because I have a reason for insisting that you use a text file. If you have not used text files before, please, this is the time for you to use it. So I mean exactly what I've said there. The program should maintain a list of books in a text file, not a database, with the format shown below. So I've shown you the format. It should have a sequence number, title, authors, ISBN. Maybe you should even have just one author, it doesn't matter. ISBN, publisher, and date of publication. So for each book, you record in your text file those details: sequence number, title, author, ISBN, publisher, and date of publication. Now, this is the way you distinguish books. No 2 books should have the same ISBN number. So go into any textbook, you'll find out what ISBN numbers are about. But make sure that no book has the same, no 2 books have the same ISBN number. That is what I want you to program. And remember, it's a standalone program. So by now, I believe you should have developed that program. A simple online bookshop that can allow you to search for a book, purchase it. I don't know if I even put in there to enter, enter books, new books if you have, but it really doesn't matter. Maybe I should include that. I should add there, you should be able to enter details of a book. Suppose you have a new book and you want to enter it into the catalog, then you can be able to do that. So I think I will add that. Now, that is what I expect you to program. So that now when I'm asking you if you have programmed that and everybody's quiet, I'm just amazed. Is there any difficulty with that programming project? To program such, to create such a program or to develop such a program? Is there any technical issue there? Is there any technical issue in doing that?
No. And I have a question.
Yeah.
Yeah. Could we decide to separate the values using commas, like the serial number, going to the title, to the authors, the ISBN? We have
No.
a comma as a delimiter.
No, I don't want you to use commas.
So
Just the way I put it. Just the way I have put it. Because I know you want to start using JSON and things like that. I don't want you to do those kind. I want a simple text file. And that's what I'm saying. If you don't know how to use text files, this is the time to learn it. I believe you should have been taught about text files in your first year course. If you are not, then it's time to read it up. And it's nothing complicated.
then can it be a .txt file?
Pardon?
But can it still be a txt file and I use commas inside?
A TXT file and?
I use the commas inside.
No, I don't want you to use commas. I have insisted on that. The way I have drawn that table is the way I want your text file to look. Because it's easier for you to do that. I believe that's why you're insisting on having these commas. It's an easy thing to do. But I don't want you to do that because there are specific skills I want you to learn by putting that table that way. And they will help you when it comes to when you start programming communication between programs. This one, there is no communication between any program and another. This is just a program running on a single computer. But I want you to program it because we are then going to take this same program and develop the other versions of the program, like the iterative connectionless, iterative connection oriented. We will use this same program I'm asking you to program. So I want you to program it in advance. Because when we start doing network programming, these other issues like searching and so on they will not be the core of what you are supposed to learn. So I want you to do away with them early enough so that now you can focus on the important aspects of network programming in assignment 2. So for now, I just want you to do assignment 1. I even think I gave you a deadline, which is Friday the 12th. So I'm going to create a folder on Friday the 12th. I want that program running. I think that means you have 1 more week. Ignore assignment 2, 3, 4, 5, and 6 for now. Just work on assignment 1. And you will be happy you worked on it. when we start doing assignment 2 and 3 and 4. So what I want to know, is there any technical difficulty in doing assignment 1? And what is that difficulty?
Just two questions.
Mhm.
First of all, the final program interface can be anything. I'm asking just in case because
What do you mean by anything?
command line or GUI.
I even don't want a GUI interface.
Okay.
I even don't need a GUI interface. Those are not the aspects that are important in this particular class. I don't know if you want to do a GUI interface, but for me, it's irrelevant.
No, I wanted CLI.
Pardon?
CLI is okay.
Yeah, command line is fine by me.
And for assignment 1, are we dealing as one actor interfacing the text file or two entities?
Are you doing what?
Retrieving the data from the text file, like implementing the functions.
Yeah, I knew that's that. But you see, initially, even if you use a text file, you'll have to read what is in the text file and bring it into your program. And you will have to store it somewhere in your program. I imagine that's what you would probably do. So maybe you can just start by creating a data structure in your program, maybe kind of a record or something. And once you are sure that the program is running, then you can now see how to write it to the file and read it from the file into your data structure. But I want the data to be permanently stored in a file, because obviously in your data structure, when your program is not running, then obviously there'll be nothing left in memory.
Yeah, I was just asking because it seems like there will be two actors, like for the actions for purchase item and pay for item.
Yeah, actually, I don't know, maybe that's a repetition. Just a minute. Purchase.
So are we dealing with a
Purchase
client
is where
server
you
mode?
say what you want to purchase. Which book do you want to purchase? And you give the details of the book. As to whether you want to embed the pay inside the purchase, I don't know whether that's what you're asking.
No, I was asking for the program now as we develop it. Are we developing it in mind that it's only one actor who is interfacing with the text file, or it's a client asking a server for actions to that text file, like now paying?
It really doesn't matter. At the moment, it doesn't matter because that thing is on your computer. So you are the client. But of course, once we start doing network programming, then you realize there could be many clients running around the world, because you will not be the only client. Think of Gmail, for example. How many clients are there to Gmail? Millions. But for you, who wants to interact with Gmail, you are only concerned about you. You're not concerned about the other clients running wherever they are running their program. So it's the same thing now. You're only concerned about the you who is going to use this program. But once we convert it into a client server program, then we can have 3 different computers running the same client. It doesn't matter. And that will now depend on how we program our server to be able to interact with 1 million clients. So it won't be about the client, it will be about the server being able to receive requests from all these clients. But since now we are not implementing a server, just think about the client, the one client who is going to use this program. Then when we learn how to create, to develop servers, we will think about those issues. But it will not be the client that will change. It is the server that will have to change. I don't know if I'm answering your question.
Yeah, perfectly. It's a client now.
Yeah, the client part will remain intact. And it will be the same client for all the millions of users around the world. So this is a program, if you mean to program it even one day, you will have this program running. I think you are just not doing what you're supposed to do. Maybe you had not understood what you're supposed to do, but I hope I have explained it. So by 12th, just make sure this program is running. And I think I will be thinking about how to initiate lab sessions so that we also work on this thing in the lab, so that I can actually confirm that you are programmed. But you will upload this program by 12th. I will have to find a place for you to upload it. For the different groups, I think there are 15 groups that I was given. I will upload that list of groups in the classroom as well. Now, the latter part of that assignment was said you should also provide a connection-oriented version with client and server running on the same machine. Now, as of now, we haven't done enough because I have to still talk about client and server and what they mean and how they interact. So even that part you can ignore. Just do the part I have already described. But it is possible to run a client and a server on the same machine. So the first thing we will do once we convert our program into client and server, we will run it on the same machine. Then we will now remove the server and run it on a different machine and have several clients talk to that single server machine. But because we have not talked about the API that I was talking about, which is for programming, let's even leave that part alone for now. Just do the first part, which I have already described. Just make sure it's working. I believe you will understand the importance of doing that, of writing that program. Maybe now you may not appreciate it, but later you will appreciate why you wrote it. Okay, so 12th, just make sure that program is running. I'll create a space for you. I hope that the classroom now allows you to upload files, but we will find somewhere for you to upload it. So I'll stop on that unless somebody has a question.
Yes, I have a question on the languages we're supposed to use.
That I'm surprised you're asking that, but I think I made it clear that we are programming in C.
Okay.
Yeah.
Is C++ an option?
Yeah, it's an option. C++ is another option. C, C++, not C hash, C, C++. Those are options you can use. But I don't expect you to use object-oriented programming. I know C++ allows you to create objects and classes and things like that, but that's not why you're using it.
Okay, can you please then add all the details in the assignment, because it's also actually labeled it's due on 12th of May, not April.
It is 12th of May.
Yes, and the assignment
which
was
month?
listed April.
I think that's not correct. It's 12th of April.
Yes, and the assignment on our side is also says it's 2022, so it's not. That's why everyone actually 2022 on my side, so that's why no one actually even saw it.
Where is it saying 2022?
That's what I can see on my side now. It's actually
Which
Feb
part?
2020.
Okay,
The assignment was posted. The assignment was posted in 2022.
Oh, okay.
Yeah, so for me, I never thought actually it's a part of our work or assignment, so I was not aware.
You didn't? Oh, okay, that's interesting. When did I thought I posted it recently.
Oh, for my part, actually, I was not aware there's an assignment that is due or pending.
Oh, you are not even aware of it?
Yes, or something that
yeah, most of us are not aware.
Okay, but do you have this document? The one that I've shared, the one that I'm projecting?
Yeah.
Yeah, I've just scrolled the class. It's under 2022. It's actually at the last part or somewhere there. Yes.
I think what I did, I just took the assignment I gave them last year and changed it. So maybe I should look at what I did, but I basically took the assignment I gave them last year and made some changes to it.
Yeah, so if someone actually has to see the assignment, they have to scroll through the classes up to 2022, like down.
Okay.
Yes.
Right, I'm sorry about that. So I thought I had communicated and maybe I didn't. So, okay, that explains the silence. So is this the new assignment? It is. Now you see it is written CSE 322 Programming Assignment 2023-2024. So maybe I just did not communicate that I've put up an assignment that I want you to start programming. In fact, I did it before Easter and I thought you would look at it over Easter. But we still have time. It's a simple assignment. I don't think it's anything complicated which you can't program. So you still have at least a week. Just do that assignment 1, and I will try to make the corrections necessary to make sure that you all understand that there is an assignment for this class, the 2023/2024 class. So I will check what it is that I need to change to make that as clear as possible. Is that okay?
Yes, that's fine.
Good. All right. So now we go back to the transport layer, because as we have been trying to do, we were trying to explain why the transport layer is important. That's what we started with last time. And I hope that you are beginning to build your understanding of why your programs will run on top of the transport layer. But before we start programming, before we start programming, I just wanted you to be familiar with what goes on underneath your program. It is important for you to understand that what goes on within your program, or what makes your program run the way it does. And that's why we are doing the transport layer. So I'm looking to project our notes for today. Now, this class is supposed to have 90 students, as far as I know. I can see 58. That means that a big chunk of students are not here. The reason for missing class, I don't know. But is the class rep here?
Yeah.
Is the class rep here?
Yeah, I'm here.
Please, can you ask all those students who have missed class today to write me an email and explain to me why they are not in class?
Okay.
Yeah. And I shall make it a requirement. If you're not in class, just write me an email and explain to me why you are not able to attend. Good. So I want to remind us of what we have done so far. I started by explaining how the network layer works. And we ended up saying that the network layer, which uses IP, first of all, we said all the networks have only layer 1 and layer 2. But when they're on the internet, they include the IP and TCP layers. So we talked about the IP layer being a connectionless protocol, which basically means if you're using IP, the application does not have to go through the 3 phases of connection establishment, send data, and then terminate connection. Then we tried to explain why was it developed as a connectionless layer, and what connectionless even means. And we basically described a connectionless network layer as being unreliable, which means it loses data, means it does not guarantee that data will arrive, does a best effort to try to ensure it arrives at the destination, but there is no guarantee. Then we said that applications, though, require something reliable. You do not want to write an application that will not send the request to the destination. Or you ask to download a page and you only get parts or bits and pieces of that page because some of them got lost. So we said between the application and the network layer, there has to be another layer that, tries to make the network, which is obviously unreliable, tries to make it reliable for the sake of the application. So we are now looking at that transport layer and what it does on behalf of the application to try and give the application a more reliable communication platform. But you have to remember that the transport layer is built on top of the IP layer, which is already unreliable. So how does the transport layer deal with the unreliability of the network layer? How does it deal with that? And today we shall start on connection establishment. And we shall be trying to see how the network layer tries to overcome the unreliability of the IP layer. But so today we are starting on how the transport layer works. Remember, the transport layer sits between the application and the network layer. It's somewhere in between there. So what does it do? How does it do it? So the first thing we shall deal with is the addressing. And then, as I said, we shall deal with connection establishment and connection termination. There is a part 2, which is already in your classroom, which we shall deal with once we finish with these 3 topics. So why is addressing important? Addressing is important because when you develop an application, the application, remember, sits on top of the transport layer. So if you look at this diagram we have here, you realize that there's an application running here. So on this layer, we have the application. Here we have the transport layer, and then we have the network layer, which I've just said is unreliable. Now, this application here is trying to communicate with another application on a different machine. So on this network, there's also the application. On that machine, there's an application, then there's a transport layer, then there's a network layer, and other layers below the network layer. So these two applications are trying to communicate. Why is addressing important? Addressing is important so that we know which application is talking with which one. Remember that on a network, there are many machines. So assume there are other machines on the network, and we also have, maybe we have another machine here, and there's another application also on this machine. How will these senders differentiate these two applications when they want to talk? There's another application here. So if this is the sending application, how will it differentiate between this first one on host 2 and the one on host 3? It will differentiate them by an address. It has to provide the address of that application it wants to talk to. So we must come up with an addressing scheme by which one application will say which of the applications on the network it wants to talk to. That is the idea. And this addressing scheme will be the addressing scheme provided by the transport layer. Remember, the IP layer already has an addressing scheme by which it differentiates all the different computers on a network. So IP layer has its own addressing scheme as well. But now, since the transport layer is the one that takes control of the applications, or is the one that provides a base for the applications to run, it must provide a way to distinguish the different applications that are running. So it must provide an addressing scheme that all programs know. Right. So how do we address applications? We're actually talking of how to address applications or processes, running programs which are processes. So addresses are used to identify the target process. As I've said, a sender is sending to a process. Which process exactly? Now, so typically we use a composite address. And this composite address consists of two things. It consists of the machine on which that application is running and the address of that application on that machine. Because remember, a user could run 100 applications on their computer, or 3 or 4 applications at the same time. So if a certain application is sending a message to your computer, to one of the applications on your computer, they first of all have to identify that this program is running on a particular computer. But on that computer, there are 4 programs running. So which one exactly? So that's why we say you must give a composite address. One that identifies the machine on which that program is running, which basically is the IP address of that machine. And the second component of that address is which application, because you do not assume that there's only one application running. There could be more than one. So you have to say which. So that composite address typically consists of what we call the network-wide IP address, which you already know about, and then the host, and then the network-wide address of the host machine, and then the transport protocol address, because you say that these addresses belong to the transport layer. So the transport address. Now those transport addresses, so now we leave the IP, the network address, because we already know about IP addresses. So now let's talk about the transport address. These transport addresses, they go by various names. The first one there is the transport service access point, something I believe you have seen a lot. In these diagrams, you always have an access point. I'm not sure that this diagram actually brings it very well, but these are access points. That is an access point, a point at which you access the layer below. So for the application, this is the access point via which they talk to the transport layer. Now notice here, there could be 3 applications running, or 1 application using 3 transport access points. So there's that one, there are 3 addresses there. So if there are 3 applications running, each one of them will use a specific address, transport service point. So sometimes they are referred to as access points. And that's a generic term. I think it was what? That term was created during the time when the OSI model was being developed. They were actually called transport service access point, network service access point, and every layer had its own service access point. So that was the generic term that was given to those access points by the OSI model. But the internet uses a different name called port, but it still just has the same idea. It's the point at which the upper layer is accessing the lower layer. In our case here, it is the point at which an application is accessing the transport layer. So on the internet, they are called ports. I think on ATM networks, they have that name, AAL, service access point. So they go by various names. This address, we are talking about the transport address. So I have just said that the address is composite. It consists of the host ID and the port ID. So for the host ID, this is the address that identifies the device you're talking about, or the computer that is hosting that application. In the case of the internet, it's basically talking about the IP address. If it's another network, you will have to find out what type of addresses it uses to identify the different hosts. Okay, so now we go to the transport address, which we said on the internet is called a port. So since we are going to be developing internet applications or TCP applications, let's just deal with it as a port. So a port basically represents a TS user or a transport layer user at a specified host. So here we are assuming that since a port is basically a service access point, it is addressing a particular user of the transport service or transport layer. So it represents a particular user. So let me go back to this diagram here. Here, assume we only have one application. So let me draw my application that way. So if this application is the one running here, it can be seen as a transport layer user because it is using the transport layer to communicate with the other application on the other side. Since it cannot do it directly, it has to request the transport layer to send its message to the other application. So we are therefore calling it the transport service user or transport layer user. But since it's a service that the transport layer is offering, you can as well just call it a transport service user. So that's why we are saying here that this port represents a particular user at a particular host. Now, when that transport user is using the service, usually it uses the service to send a message to a particular application. But the way it does it, it doesn't send a message to an application directly. It sends a message to the port which that application is using. Since, let me put it this way. So this application is using this port. This other application is using a different port. So usually when a user is sending a message, it doesn't send it to the application, it sends it to the port which the application is using, because then this user can then access that whatever has been sent through that service point. Because this application that is sending uses this service access point to give whatever it wants to send to the other application. It gives it to the transport layer. So now the transport layer has the message. Now the transport layer sends the message to the other side, and then this transport layer receives it. So when this application wants to receive this message, it will have to access it through this point. So it will request the transport layer to give it the message which has been sent to it. So in a nutshell, what I'm saying, when an application is sending a message to another application, it sends it to the port which that application is using. Because through that port, that application can access the message. So the source process sends a message to a port, and the destination process receives the message from the port or through its own port. So that particular port must have an address. It has to have a way to identify it. And that's what we are trying to get at. How do we identify the port we are sending it to? So how is, first of all, a port implemented? Now, please remember that a port differs from the operating system ID. Remember that on an operating system, every process has an ID. So they are process IDs. We are not talking about process IDs. We are not referring to how the operating system distinguishes the different programs running on it. That's a totally different mechanism. But every program running within an operating system is typically, the port is typically implemented as a message queue. In this sense, as I've explained to you, the sending process takes a message and passes it to the transport layer through the port or through its service access point. The transport layer takes that message, sends it to the other transport layer, the peer transport layer, and the transport layer receives the message. So where is this message kept before the process decides to want it or to ask for it? It is stored in a queue. So therefore, basically, when you talk about a port, it is a queue where all the messages for the process are stored until the process requests for them. So all the messages that have been sent will be stored in that queue. And when the process asks for the message, they'll be given one by one. And if there is no message, they'll also be told, look, at the moment, I have no message. So the port is implemented ideally as a queue. Now, on this side, also there's a queue. Remember that when this process has something to send, it gives it to the transport layer. The transport layer puts it in a queue before it sends it, because remember the transport layer has to send it. So it can also have a queue here where it stores the messages which it needs to send to the other side. So there's an input queue and there's an output queue. But we'll talk about that later. So this thing we are calling a port is basically implemented as a queue, but still it has an address. So how does that queue work? When a message arrives, the protocol appends the message to the end of the queue. Now we all know how queues work. Now, should the queue be full, what happens? The message is discarded. And that's why flow control is very important in transport layer. Because if flow control is not done, then messages will get lost. If the queue is full and a message arrives, the transport layer just gets rid of it. Now, when an application process wants to receive a message, and remember when it wants to receive. So all along, we've been seeing the lower layer receiving a message and passing it to the upper layer. Receiving it, removing the wrapper around it or the header, and then passing it to the upper layer. When it reaches the transport layer, it doesn't happen that way. The transport layer will remove the header, but it will put the message in a queue until the application asks for it. It will not pass it up when the application is not ready. So when an application process wants to receive a message, one is removed from the front of the queue and passed to the application. If an application asks for a message and the queue is empty, then the process is blocked. And this is an operating system term which you're already familiar with. When a process cannot proceed for whatever reason, it's not able to proceed, it is typically blocked until it is able to continue. But typically it's blocked when it does an input-output operation. It is blocked, and when that operation is over, then it is unblocked and allowed to continue using the CPU. So if the queue is empty, just like any other process, remember it's trying to do an input, it will be blocked until the message becomes available. And that blocking term is important. It's important, you'll have to remember it when you are writing your program. That when your program requests for a message and there is no message, your program will be blocked or your process will be blocked until the message is available. So I already explained that there is need for flow control because if messages come in too quick and the buffer gets full or the queue gets full, then the messages will be dropped. Now, in that composite address, we say that one part of the address is the IP address and the other part of the address is the port address. I don't know if I've already said it, but the port address is simply just a number. It is just a number. Just like the process ID, but it's not the same as a process ID, it's a number. So in this particular case, we have given an example here. The composite address will have 128.3.2.3. That's an IP address. Then the second part will be the port address, which is 53. So it's just a number, which means if you have several programs running on a given computer, each one of them will have a port number, which will identify its service access point. It will just be a number. So if you want to send a message to that process, you'll have to identify it by the machine address or the IP address plus its port number. Then the transport layer will know exactly which process you're talking about. So which means you cannot have two processes with the same port number on the same machine. Otherwise, there will be a problem there. So I don't know if anybody has a question on that, on the addressing, how to address processes when you are sending a message to them, if you're writing network programs. Okay, so I'll continue. I hope that we are together.
Yes.
So, is there a question?
Yes, I wanted to ask.
Yeah.
The messages are in packets, eh?
The messages are?
The messages are in packets.
Yes, the messages will be sent as packets.
Okay. And the composite address would be part of the, like the frame that has been sent or the message that has been sent.
Okay. I'm trying to say that in your application, the application you are writing, in the application that you are writing, if your program is the one that wants to talk, for example, to a server, you'll have to specifically say which server you are talking about. And remember, the server is just a process as well. So you will say on which machine is that server and which port it is using. I'm talking about your application. Now, suppose your application is sending a file which is 10 GB. It is not the responsibility of your application to actually break down the data into small packets. So it will just say, look, I have this file I want to send to that application. Then that file will be broken down into small packets, and each packet will be sent to that address that you specified in your application. But of course, in that packet, there will have to be some information that says which port it is going to. Because they are all going to the same port, they are all part of the same file, but they are all going to the same server, which is working or receiving messages at a specific port. So because there will be independent messages through the internet, each of them will carry independently that port number. Are we together? Edith?
Yes.
Right. I'm about to talk about what is contained in the packets. I haven't said it yet, but I'm about to talk about it. But that's the gist of it. In your application, you just say, look, I have this file to send. Please send it. Ahmed, Amina?
Oh, sorry, it was by mistake.
Okay, fine. Okay, so assume that whatever you are sending has been passed down to the transport layer, and it is broken into multiple messages. Then that port number must be included in the transport header. Remember, there's a transport layer header, there's an IP layer header. But remember that in your application, you said both the IP address and the port number. So that information is with the transport layer. It knows both the IP address and the port number of the application you want to talk to. So the transport layer will take only the port number part of that address, of that composite address, and put that port number in the transport layer header. So somewhere in the transport layer header, there is a space for a port number, which will serve as the destination port. But since the application that is sending also has a port number, the port number of the sending application will also be put. So there'll be source port number and destination port number in the transport layer header. Then the transport layer, of course, will take the IP address part of the composite address and pass it down to the network layer. And the network layer will take that IP address and it will put it in the destination IP address part of the header. And since the machine on which this program is running, the IP layer knows its IP address, it will also put the source IP address. So please notice that the IP address has come from the application. It has bypassed the transport layer and it has been sent down to the IP layer. The port number has also come from the application. It has been passed down to the transport layer and the transport layer has put it in the transport header. So all I'm trying to say is that the address comes from the application, because you are the one who knows what communication is about, who you want to communicate it with and why. The other layers are just adding this information to their headers. So that's really what this slide is trying to say, that the port number is put in the transport layer header, both the source and the destination, and the IP layer, the IP address is passed down to the IP layer, and it is also put in the IP header, both the source and the destination port. Now, in your application, you might not have to specify the source composite address because the operating system knows it. So when your program wants to communicate with another program, all you have to do is actually put in the address of the destination, because already the operating system has that information. So you don't have to tell it what the source is. It already knows which program is running and what is its port number. So you might not have to say in your program the source. All you have to specify is the destination composite address. Right. So in this diagram, you see the IP header. It doesn't give details, but you already know how the IP header looks like. If you have forgotten, please review again the IP header and the details in the IP header. But the most important for our purpose is the IP source address, source IP address, and destination IP address. Now look at the header for the transport layer. And remember, the transport layer has two different versions of the transport layer. There's TCP and there's UDP. In the case of UDP, and UDP is the connectionless version of the transport layer. So the transport layer is connectionless and connection-oriented. I think we talked about it last time. So UDP is the connectionless version of transport layer. So it has only a source port number, destination port number, the segment length, and the checksum. So that's what you find in the transport header over UDP segment. Now in the other connection-oriented, you have more things, because remember, connection-oriented is reliable. Connectionless is unreliable. So in the case of connection-oriented, notice that you have their source port number, you have destination port number, which is what we've said, but it has additional things. Particularly, it has the acknowledgement number and the sequence number. And that tells you it's reliable, because when you send something, it must be acknowledged so that you know whether to retransmit it or not. So it has both the sequence number and the acknowledgement number. But it has many other things, which I think we shall talk about later. It has the length, the header length. It has a window. That means it's using the sliding window because of the reliability it wants to achieve. So it has a sliding window protocol there, but it has also a checksum and some other flags, which we shall talk about. There are 6 bits there called flags, which are very important when you're creating connections and things like that. But at a later time, we shall go into more details about this header. But for now, all you need to know that it contains a source port number and a destination port number, whether it's TCP or UDP you are using. So all the packets that are coming from a single source to a given destination will contain the same port number and the same source port and destination port. Now, so we are talking about addresses, remember. So in a connection-oriented transport layer, assume you are writing a program and the program is using the connection-oriented version of the transport layer. As we said, the client process initiates a message exchange. In other words, in your program, you have to initiate the exchange. Yeah? With whichever program you want to communicate with. Most likely it's a server you are talking to. So once a client has contacted a server, the server knows the client's port and can reply to it. Now, the real problem is, how do you know the server's port? Before you can talk to any program, you must know its port number. And you must know its IP address before you talk to it. But now the question is, when your program initiates a communication with a server, as we said, the transport layer will include both the source and the destination port. And when that packet arrives at the server will see the source port and the destination port, which belongs to it. So from that source port that it has received, it will know the port number of the program that sent it that message. So it can simply reply because it already has the port number from the message it has received. But the question is, how did the client know the port number of the server? How did it get it, or where does it get it from? So think about it. When you're running a program and you want to communicate with a web server somewhere out there on another machine, where did you get that port number to put in your program? Where do you get it from? That's the question you must try to answer. And this question has been answered in many ways, in different ways. In other words, there are different ways you can address that problem. One is that the user or the programmer must know the address ahead of time. So assume I want to access a web server, or I want to access a bank web server. For me to know ahead of time, maybe I would call them. Or there's somewhere I can get that information so that I can now put it in my program. So I get to know it ahead of time and I enter it into my program. So how you get to know it, as I said, you can call, or there must be somewhere where you get it and you put it in your program. Now, of course, that's not a very good idea, because on the internet, how many servers are there? If you want to access a server in Spain, who will you ask? Who will you ask what is the port number? And how many times you have to ask that question for you to talk to all the different servers around the world? It's a difficult process, but it can work, only that it's not practical. The second way you can do it is that servers can accept messages at well-known ports. And this is what is typically used. Now, notice there I put in some servers well-known ports. So the domain name server always runs on port 53. The mail server always runs on port 25. The web server always runs on port 80. So that's a universal standard, agreed upon standard, that all web servers run on port number 80. So when you want to access a web server, you don't have to ask yourself, but which port is this web server using? You know it is running on port number 80. On all the computers around the world, the web server runs on port number 80. You don't have to ask anybody. So that simplifies things. So, and this is what is normally. So all the servers have well-known ports, and these ports are widely published. Just Google the well-known ports for servers, you will find that information. And there are more servers than these three I've put here. So that's another way to do it. Now, of course, you know that servers have domain names, like for example, www.unbi.ac.ke. Now, remember that a composite address has both an IP address and a port number. So how do you get the IP address part of the web server? That web server probably has a domain name. So this domain name service will translate your domain name into an IP address. So during runtime, you can just say, look, I want to communicate with the web server at Nairobi, at, let's say, another university. Let's say Jomo Kenyatta at runtime. You just say, I want to communicate with a server at Jomo Kenyatta. It's a web server. So you give its domain name, www.someotheruniversity.ac.ke. And at runtime, that domain name service will be translated into an IP address. Of course, you don't know the IP address, and you don't have to know. But at runtime, the domain name service will be contacted, and it will respond with an IP address for that particular web server. As far as the port number is concerned, you don't have to think about it. You don't have to guess. It's running at port number 80. So in the composite address, all you have to put is www.unbi.ac.ke, that's for the IP address, comma, port number 80. If it is web server. If it is a mail server, you put port number 25. If it's the domain name server, port number 53. But as far as the IP address is concerned, you put the domain name, www.something.something.something. So that now at runtime, it will be translated into an IP address in your program, and then your program will communicate with that server. And that's a good thing, because then that particular program does not necessarily have to run at a specific machine. If the management decides it's running on machine A, they will change the address. If they decide it's running on machine B, they will still change the address, but the domain name remains the same. So your program is capable of running anywhere, and as long as that server is somewhere there on the internet, and the DNS knows about it. So that's the format that's normally used. Is easy to use that kind of thing. Now, here I just want to describe what happens when your program is running and contacting a server. Any server. Of course, in this particular case, we are dealing with a very specific server, which is the time server. I think it is the time server we are dealing with. So this is what you would find in your application, or how your application would run. So the client application, so we assume it's a client server type of program with one client running on machine A, server running on machine B. So the client application, assume the client application wants to find out the time of the day. It issues a connect request So how your program says, I want to connect to this program, or I want to talk to this program, is you put a command in your program called connect. And that will tell the transport layer that you're trying to connect to a particular program. But in that program, you have to put the composite address, which we talked about. So in this particular case, this connect command requires that you issue the port number for the source program and the port number for the destination program. In other words, the destination program is running at port number 1522. The sending program is running at port number 1208. So as I said, in the connect request, actually you don't have to put in the port number of the source because the underlying operating system knows. So you just have to put there 1522 and the IP address of the receiving machine. But you use the command connect to initiate that connection. Now, the assumption here is that that time server is running at a port number 1522. For you to say connect to port number 1522, it means that the time of day server is running on whichever machine it's running at port number 1522. And it is already waiting. Remember we said that sometimes the communicating programs need to synchronize, and this is one way in which they synchronize. The server is already waiting for clients to contact it. And that's how it normally happens. The server never comes to an application to say, look, please ask me for something. No, they don't do that. They just sit there waiting. If no client wants anything from them, they just sit there waiting. But if a client asks them for something, they will respond. Like in this case, they are being asked for, it's being asked for time of day. It will respond. So server is always waiting. Server runs 24/7. But clients don't run 24/7, but servers run 24/7. So they must already be in that waiting state where they've already started running. They've already created that queue we talked about, and now they are waiting for requests to come in. So here we assume that this time of day service, it's already running and it's already waiting. So once you say once you issue the connect request to the underlying transport layer, then the transport layer initiates the connection establishment between the two processes that are running. Remember we talked about the transport connection, which we said is not a physical connection. So the transport connection will be created by the transport layer. We shall talk about that when we are talking about connection establishment. But let's just assume that a connection is then established. If that server exists, if that program you're trying to talk to really exists, the transport layer will connect to it. It will create a connection. And that program will already know that there's another program wanting to connect to it. It will be fully aware of that. And they will have exchanged a number of messages. So once the connection is established, then the application process then issues the request it wanted to issue, which in this case is request for time of day. Now, when the server receives the time of day request, of course, it will look at the time, it will take the time, put it in a message and send it back to the client. So the time server will respond with the time of day, which will be in a message. And when the message arrives at the client, of course, it will also be put in the queue. And then it will be passed on to the application when it requests for it. And then the transport connection will then be released. In the case of TCP, releasing a connection, you issue the command close. To initiate a connection, you use the command connect, but to close, to terminate, you use the command close. And again, you have to say which connection are you closing, because an application can make several connections. So if you make a connection to server A and another connection to server B, and you want to close the connection to server B, you have to say, and again, you have to give that composite address we talked about. So this is just a diagrammatic representation of how an application connects to the server and asks for what it requires, and then obviously finally it will terminate that connection. But notice the transport connection. The transport connection is only known to the transport layer. If you look at the diagram on the left-hand side, there's an arrow pointing there to a transport connection. We say the transport connection is a virtual connection. It is only known to the two-end machines because the transport layer only runs on the two-end machines. So it will only be known to the two-end machines. Okay, so we were talking about how do you know, how do you get the server's address? So we have looked at two ways of getting it. One is you had coded it and presumably you had gotten it from somewhere earlier, or you put some data in your program which can be dynamically processed to get that information. Okay, a third way is to use what we call a proxy server. Sometimes the well-known port is just for what is referred to as a proxy server. So a proxy server is a server that runs on a well-known port somewhere. And when you want to communicate with a certain application, you contact the proxy server. By that time, the application you want to communicate with is not running. But once you inform the proxy server will start to run that application, and then you can communicate with that application. Remember that in the second method, the server was already running and most likely consuming resources, because for a running program, you must have some memory, you must have some process ID. In other words, you're already consuming resources by just running, even if you're not processing anything. Some data structures are there in the operating system to say, oh, this program is running. The application is most likely already loaded in the memory. So you're consuming resources. That application is consuming resources. But in this one, the proxy server, the process is not running. That program you want to communicate with is not yet running. But you contact the proxy server and you say, look, I want to talk to the time of day server. Then the proxy spawns. There's that term there, spawn. It spawns the requested server. In other words, it begins to run it. So at that time, it will be loaded in memory and so on. You will just basically initiate the running of that program. And when that program is running, of course, it will be given a port number. It will be given its own port number. And of course, the IP address, of course, is the same IP address as that of the proxy server, but it has its own port number. So once the proxy spawns that program, of course, it knows the port number because it's the one that spawned it. So it knows the port number. So now the proxy server will respond to the client that made that request and say, look, I know where that program you want is running. I know its port number. So it will give the port number to the client, and the client will now connect. It will now connect to that process. So look, first it connects to the proxy, asks to talk to a particular server. The proxy responds and says, okay, I know its port number. Then the client will now connect directly to that program through its port number. and then ask for whatever it wants. Now, in the meantime, once the proxy has responded to the client, it goes back to listen. What does this listen mean? Listen is just what I had said in the second situation, that the program was already running. The server was already running at a well-known port. It was already running. When it is in that running state, it is referred to as listening. It is actually waiting. I think I used the word waiting, but the real term is listen. It's listening for any messages that are being sent by clients. So what we are saying here with the proxy has already responded to the client and given it what it wanted. So it goes back and waits. If there's another client who, for example, may be wanting to talk to another server. So in this particular method, servers are created as and when needed. And once they finish, they terminate. If there's no other program wanting to use it, it's terminated. So I guess the idea here is to try and minimize resources. Don't run servers that are not required, that nobody requires them. There's no point to waste memory and so on, running a program that nobody is interested in. So here's an example of the proxy server in operation. On the first part, you have the first part refers to the proxy server running. So notice there's a user on part one host 1, and there's a proxy server there running on host number 2. So assume the user wants to talk to the time of day server. It will make a connection to the proxy server, here referred to as the process server. And the idea here is that this proxy server, the address of the proxy server is well known. So everybody knows that if you want to run any program, please talk to the proxy server. The proxy server is running on this machine at port number such and such. So that address has been published widely and everybody knows it. So the user contacts the process server and say, look, I would like to communicate with the time of day server. Then notice that in the second part of the diagram, part B, the proxy server has already spawned a time of day server and has already responded to the user. Now the user has connected directly to the time of day server. In the meantime, the proxy server is listening and waiting for any other client that wants something from it. So that's another way to do it. So that when you are, the question we are trying to answer, how did the client know where the server is running? So you know through the proxy. Another method, here we call it the name server. Here we have only a single well-known port, that of the name server. It's like the proxy server. Only now it's a bit different, right? So you know where the name server is running, and that's the only port you have to know. Just like the only port you had to know was the port of the proxy server. So here, the only port you have to know is the name server. But now the name server here is keeping a register, a database with all the servers and where they are running. So when you connect to the name server and you ask to contact a given service, and you say, look, I don't know, I want the time of day service, but I don't know which port it is using. Then the name service will look through its register. It will find out where the name service is running, and it will send that information back to the client. So if you look at bullet number 3, it says the user connects to the name server, requests for the port it should use to talk to a given service. Now, of course, the user must specify the name of the service, for example, time of day service. So you say, I request for the port number for time of day service. And the name server will look through its register. It will find out the IP address and the port number of the time of day service and send it back in a message to the client. So the server responds with the port of the registered service, and the user then establishes a connection with the desired service. And again, the benefit of this is that you don't have to know too many servers. You don't have to know where every server runs. You just have to know where the name server runs, and you ask the name server. And these servers that you are contacting, they can change location. As long as when a service begins to run, it registers itself with the name server. It must register itself with the name server. Before you can find it, it must have registered itself. So that would be a process that would run in the background. When a server begins to run, it registers where it is running and the port number which it is using, it registers it with the name service. Then when you ask the name server will tell you where it's running. So these things just make writing the program easier. Much easier than that first one we talked about, where you have to know. It is up to the programmer to know. How you know? No one wants to know. So all these methods have been used. And I think we come to the end of this addressing issue. It's an important thing for you to program. You must know the addresses of the programs you want to connect to. And we said that the one you're going to use is the second one. Now, actually, let me not say the one you're going to use is the second one, because other than the assignment, I think there's assignment 4, which I've asked you to be able to talk to any server anywhere around the world. So that one, you will know that most servers or all servers are running on port number 80. But for the server you're going to write, which is going to be the online bookshop, you can choose any address, or you can allow the operating system to choose any address for that server. So that one you will just have to know. That one, perhaps you'll use the first method. You already know which port number it's using and which machine you are running it on. Because it's only servers that register themselves, but all the other ordinary machines, they don't need to register themselves. So in your case, you'll be just using your own ordinary machine. So I guess you'll use the first method. You'll take the client part, which the user will be using to ask for the books that are online and to purchase them and register them. You run that on one part of one machine, and then the server, which actually holds the register of books, will be running on another machine. But you will have to get a port number for that server, and you'll have to put it in your application on your server side, on your client side. Right, any questions? Muhalisi Edwin. Did you raise your hand? Okay, anybody with a question? Right, in summary, we have talked about the addressing method. So just try to answer my question. Which addressing method? How are the processes addressed? We've talked about it. How are processes addressed?
It is a composite address comprised of the host and port.
Good. Good. That's what I'm asking there. We have said that a process is addressed using its host address and the port number. How is a port implemented or realized?
It's a number and it's implemented as a queue.
Pardon?
The port address is usually a number and it is implemented as a queue.
And?
It is implemented as a queue.
Good. So the port is basically just a number. This number is typically selected by the operating system. Yeah, when the program begins to run, it is usually picked for you by the operating system, and it is implemented generally as a queue of messages. And we've explained how the queue works. So the means of finding the server address. Maybe I can ask two different people to explain to me how the proxy server works and how the second one works. So if you understood them, maybe the last three. So let's take the proxy server. Who can explain how the proxy server works as a means for programmers to find the server's address? Okay, Jerry, followed by Aduma.
Okay. The proxy server works by first of all, it resides at a well-known address or a well-known port number. So the client connects to that well-known port number, and the proxy server spawns the address that the client is requesting.
They spawn what?
The requested server's address.
No. They spawn what?
They spawn the port number of the server.
Okay, continue.
And then once the port number has been spawned, the proxy server allows the client to connect to the requested server using that spawned port.
Good.
And it continues working, and then it continues to listen for connections.
Good. You have understood most of it except just one term you're using there. But when you spawn a process. You spawn a process. Remember, as I said with the proxy server, the program is not running. So you spawn a process. In other words, you make the program to begin running. So you spawn a process, not the port number. You spawn a process, and remember we said the operating system gives every process that begins to run a port number, a specific port number. If it is just an ordinary process, the operating system does not have to be told that this program must run at this port number. No. So usually you can just let the operating system spawn a process and tell you this process, I've given it port number XYZ. So just that small correction, otherwise you're correct in everything, but you spawn a process, and this process, when it's spawned, it comes with its own port number, which the operating system gives it. Then now the proxy takes that port number, sends it back to the client. Then now the client can talk directly to the spawned process. Remember, it will get the IP address from the IP address of the anyway, it already knows the IP address of the proxy. And the assumption here is that the proxy is spawning a process on the same machine on which it is running. So it already knows the IP address of that machine. The only thing it doesn't know is the port number. So I hope, Njeri, you've understood just that small part that you need to clarify. You need to be...
Yes, I've understood it better. Thanks.
Okay, all right. Thanks. Now, Aduma?
Yeah, which one am I doing?
Choose. I said the last three. So the second one or the last one, since Jerry has talked about the proxy.
I'll do name
the well-known ports or the name service.
I'll do the name service.
Okay.
So I think in the name service you mentioned that services are registered with the name server. And if a client wants to communicate or connect to the service with which they want to transmit data, they send a request to the name server with the particular name of the service that they want to engage in communication with. So I'm assuming that the name server looks up the service, its register, and I don't know if you mentioned acknowledgement, but I think maybe if the service is found in its lookup and a connection is established between the client and the server, much like in the proxy model.
Say that again. I've heard you say the following. A server, when it begins to run, registers with the name service, and information is stored in a register. When a client wants to talk to any service, it already knows the port number and IP address of the name server. So it asks the name server and it specifies the service it wants to talk to. So far, so good. Then what?
I was not sure about the lookup. That's what I was saying, that the server looks up if the service is within its register. And either accepts the connection or closes the connection depending on the instance of that service being in the register.
Why are you concerned about closing the connection? Because remember, communication takes place this way. You establish a connection, send or transmit data through that connection and terminate. So the client has made a connection to the server, has then begun to communicate with the server to say, look, I'm looking for this and this service. You have said correctly, the name service begins to look up in its register. Remember, it has received a request through the connection. And now it's looking through the register to say, okay, this client is asking me for such and such a service. Does that service exist? The register says, yeah, it exists. And these are its IP address and port number. Then?
That's where now I wasn't sure, because I was looking at the TCP model from establishing a connection to data transfer and closing.
I'm not sure why this thing is difficult, but let me draw it for you. Let me draw it for you. Here is the client. Here is the server. Name server with a register. Okay? So this client creates a connection. And a connection is just a tube through which they can talk. Let's call it like it's a virtual circuit through which they can talk. So through this circuit or connection, the client sends its request. Once it has established that connection, it says, look, I'm looking for time of day service, or I'm looking for email service, or I'm looking for such, and it names the service. So that request has come here. You have said rightly, this name server takes that request, looks in its register, and hopefully finds it. So the register should tell it, okay, file service exists. It runs on computer X at port number Y. Then what?
So I wasn't sure if this is for domain. My problem is I'm not sure if this model is for domain name like DNS server models, or it means that the services are hosted within the name server and they are finding those services and the connection is either with the name server, or if the service is not there, it drops. Or if it's a DNS, it comes and finds it in the register and creates a connection with the service that exists somewhere, like a proxy, but a different server now.
Okay. That shows me that maybe there's something that I didn't explain very well. But let me just, if I'm trying to understand where the disconnect is, every program that runs somewhere on the internet has a composite address. Composite address is an IP address, 28.53.6.1, something like that. It has that as part of its composite address, plus a number like 1522 is its port number. Every process running on the internet has that type of composite address. So imagine this client wants to talk to this service. And as I said, it may be running on computer X with an IP address like 15.5.10.11. That's what X there stands for. And on this machine, it is port number 1522, which we shall represent with Y. So this program here is looking for this service, but it doesn't know where it is. So it sends a request to this name server and say, look, I'm looking for the file service and I don't know where it is. So really all this client really wants is X and Y. That's really what it needs. That's really all it needs. I know you're going into all those things about domain names and so on. Just simplify it. All it needs is X and Y. So once this thing looks into its database, it will find X and Y. The file service runs on computer X, and on that computer, it has port number Y. It will take X and Y, put it in a message, send it back and say, look, I have given you what you are looking for. Now you know where file service is running. Now, this program will then take X and Y and connect directly to create a connection direct here. Because now it knows where that service is. Remember the connect command actually just wants X and Y. I may have confused you when I said that you can use the domain service. The connect command just requires X and Y. But usually that X and Y may need you to do several things before you can get X and Y. Like the domain name service, it may need you to contact the domain name service, get an answer from domain name service, even you may need to convert whatever you get into the appropriate format. There are many things that go on. But at the end of the day, in this connect, what will be there will be the IP address X and the port number Y. All the transformations you need to do, you'll have done them beforehand. So in this case, all it needs is X and Y. And with that X and Y, if it gets it as direct as it is, all it needs is to put it in the connect command and connect to that service. So I'm not sure what was confusing you, Aduma.
Yeah, it's clearer now. I wasn't focusing only on the composite addresses. I was including now just actual human readable names.
The reason why people use human readable names is because most people can't remember IP addresses. You can't remember all the IP addresses of all the servers you may want to talk to out there. So that's why normally servers are addressed by their domain names. So that now in your program, you don't have to remember the IP address of www.unbi.ac.ke. You don't have to know it. But now when you use it in your program, you will have to have some statements before the connect. You will have to have some DNS statements where you actually contact the DNS with www.unbi.ac.ke. The DNS will respond and say, look, here is the IP address of www.unbi.ac.ke. Then you'll have to transform that answer into some. Now, when we start looking at how to program, you realize that this address has a very specific format. There's a data structure, a specific data structure you have to use to put your X and your Y. So once you get that information, you have to transform it and put it in a certain data structure and then link your data structure to the connect. Yeah?
Yeah.
So, but at the end of the day, if you look at it, all you are putting in data structure, and the data structure is X and Y. The pure X, that is the IP address, and the Y, which is the port number. So for me, I'm only looking at this point here. All the other transformations, let's leave them for the time being because they require quite some explanation for you to understand what's going on. But in simplicity, that's how it works.
That's fine.
Yeah, and so let me conclude by just saying that in the case of the second one, we say they operate at well-known addresses. So somewhere in your program, you will have to say that well-known address, especially the domain name. The domain name and the port number, you can actually put it directly because you already know it's port 80 or it's port 53 if it is this service. That one you already know. But this one you may have to put it somewhere before the connect so that then it can be transformed. You can connect to the domain name service, get an answer, and then as we said, you put it in a special data structure before you connect. Yeah. So here you'll be contacting the DNS, and the DNS is a well-known service, and there's a way to contact it, which we have not yet talked about. Yeah. Right. I think we have exhausted that issue of address. The next time we'll talk about connection establishment and connection termination. Now,